Good day and welcome to another edition of our tutorial Zero to Hero in Python programming. Today we'll be treating error and exception handling. Then towards the end we'll treat unit testing. Basically, most of us write softwares and in our head we believe they work well until they get into the hands of the users and we discover there is a bug. Then we need to fix it. That's why you see stories of images, emojis of developer trying to fix the foundation of something while users are up there thinking they are on solid structures. And same thing happens again when it comes to exception handling, when architects build a whole compound and users come in and instead of using the paths the architect laid down for them, they pass in between the lawns where they are not supposed to pass. And on the long run, you will see footpaths actually being created in between the lawns, and it's like it's part of the plan of the building. So it makes it look like a shortcut to actually get to where you are going to. So something like the architect draw a whole rectangle and users are actually looking for their hypotenuse just to maneuver their way to their endpoint. So that's basically what we want to treat here today. So without further ado, let's get started. So here I wrote a function of adding two numbers. So basically I said n1 and n2. If I run this, I've created the function add. So if I run this now, you can see it automatically giving me 30, which is the correct thing. What if I actually now write add 20 and let's say width? You can see it's giving me syntax error. If I say, okay, width is a reserved word in Python already, so let me just use we. You can see it's telling me it can't use we because, okay, we is not defined. So I have to convert it into a string. So if I run that now, you can see it's saying it can't add integer with a string. And that's a big problem. And that's just basically we actually testing our code now. What if a user actually has the opportunity of actually imputing their own values? So here is an example. So basically, let me remove the integer here. So that was me testing the code. So if I run this now, I've imputed my first number as 10. I'm asking the user to input a number. If they input 20 and I enter this and I run this, you can see it's giving me an error. It's saying string, it can't add string to an integer. And the problem is basically because we can't, when we input a number, when you use this input function, we are actually, whatever we input into it will be converted into string. If you remember when we're treating the aspect of our tutorial that dealt with input. So if we run this again and we put 40 now, if I say 20, you can see if I run this now, I get 30. Thanks for using this. And that's basically what I asked it to print. What if the user starts entering, let's say 30? You can see, okay, 30 still works, If the user actually, let's say 10, like writing 10 in words, you can see it can convert 10 into an integer. So how do we catch this? Because our users don't want to see value error or anything. They just want to be able to use their work seamlessly. So they just want an error statement that will tell them, oh, please input another number. Or please, what you inputted is not allowed on this platform. So that's basically what our users want to see. So how do we fix that? That's where the try and except statement comes in. So basically, we will try a code. Let's say result equals 10 plus 10. That's we trying it. Then except print seem like something is wrong. That is, we are telling the user, oh, if you should try this. If there's a problem, it will tell you seem like something is wrong. So if we run this now and we call result, you can see it's telling us nothing is wrong. But what if we actually quote one of our 10s and we actually call it a string, for example? This is a string now because we quoted it. So if we run this now, instead of it giving us this ginormous error that we are getting here, it's just telling us seem like something is wrong. And this one is a bit more user friendly, unlike the one we have earlier. So we can actually ask our users to input another number or something, but we'll treat that as we go on in this tutorial. So there's another thing again that we can do when it comes to try except clause. So what we basically do in try except clause is we try something, then the except tells the user what is wrong or what we want them to see. If what is going on is not working well. That's that. So here we are adding in another clause here, which is except, something like if else statement. But in the except statement, what happens is the except clause runs only when the try clause runs. You know, in the if statement, if the if statement runs, the except statement does not need to work. But here, the except statement works only when the try statement works. So when the except statement is working, the else does not work, does not reflect anything. So that's what is exactly happening here. So we fix this problem, which is 10, and we convert it back into an integer. So basically what we'll do is, since it's a string, we put inside the parentheses, then we write the integer function, call the integer function on it. So when we run this, you can see it actually worked. Then it said it all worked well. Then it printed our result. That is, it's showing us our result within the function. So that's basically what this else is doing here. So remember, else only works when the try statement works. When except statement is working, else does not work. But I will introduce you to something else here now. So, you know, since we've been using except here, to just catch any form of error. So when we get here, the except actually catches a type of error we've given it. So we can indicate the type of error you are expecting your user to have when they are doing whatever, using your code, and you actually put it here and you tell them the actual error they are having. You can be able to pinpoint, oh, this is error in play at this time. So we try two different errors here. So you can have more than one except. So we are trying type error and OS error. Basically what we have here, because we are writing into a file, we shouldn't have any error here yet. But here we are introducing another statement, the finally statement. This finally statement runs no matter what. If the try statement works, it runs. If the except statement works, it runs. Unlike the else that works only when the try statement works. So here, the finally always work. So that's why I wrote, I will always run here. So if I run this, this is actually we writing into a file on our system, and we are writing something into a file here. So we are writing it into write file. So if we run this, it actually works, and it's telling us I always run. You can see it's not giving us any error statement. So if I come back here, because we don't have permission to read the file and at the same time write into it. So we are reading the file and want to write into it here. So there will be an error. But what type of error is it? It's actually an OS error. But I'm telling it, oh, check if it's a type error, then check if it's an OS error. But mind you, because we will get error here does not mean finally will not run. It will still run. It will always run no matter what. So maybe when your user use your code and you want them to always see something no matter what. So we always use the finally. You can say, hey, you have an OS error, unlike the actual error it's supposed to write for you. For example, let me just write this code and let's see the actual error it's supposed to write for you. Sorry. Let me just copy this part and paste. If I run this, you can see the error. Oh, I'm actually indenting. It's catching the indentation problem first. So you can see it's saying not writable. You don't understand what that means. Your user cannot understand what not writable means. So but when you tell them it's an OS error, that is operating system error, it's a bit more understandable for them, or you write something they can easily understand. So having said that, let's move on. So another thing we can do here is, okay, we can use the except clause. That's what I was explaining. Except to catch any form of error. So type error, this is not actually a type error, it's an OS error we've earlier discovered. So if we now check this, oh, all possible exceptions. So it's telling you all possible exceptions. So we don't know which particular error it is because we didn't indicate any form of error in front of this place. So if you want to catch just any error, you can put this at the end of all your excepts, like all the error you are expecting. Then you are now giving them another except, like in case there is an error I did not think of. Okay, I'll print this for my user. So that's about that. So here is another one. Basically, it's the same code, but we are just using the except instead of just using type error then except. So we can use just except and finally. We can use except and finally, or we can actually indicate our types of error. That's basically what I was trying to prove here. So here is another function asking for integer. So you're asking for your user for, please provide a number. Then you are saying except, oops, that's not a number. So you created a function that asks your user for a number. If they don't give you a number, it tells them, oops, that's not a number. Then end, try except finally. So this one we always run, remember? So that's that. So if we run this and we ask for an integer, if we give it queen, oh, I spelled queen wrong. You can see it actually say, oops, that's not a number. If I call it again and I give it, let's say 10. You can see, please provide the number. It actually provided the number and it did not bother entering into the except clause. It just came straight to finally. That's basically what that is doing there. Then this another one, ask for integer. But here, basically what I did is I added a while loop. So this while loop is just helping us. You can see while true. So while this thing is still true, and since we indicated true here, it will always be true. So while true, just do this. Try this. If when you provide this number, it comes, if it's not a number, you know, it can convert into an integer. So it will enter into the except clause. So it say, oops, that's not a number. Then it will continue. Continue simply means go back to the beginning of the loop. So it continues and goes back to the beginning of the loop and checks again. So it will ask you again, provide a number. But mind you, before it gets back to the beginning of the loop, it first enters the finally. Remember, finally always run no matter what. So it will enter this finally, then go back to the beginning of the loop, then ask you for, please provide a number again. If you provided a string again, it will tell you to go back again. Then when you provide a number that can actually convert into an integer, enter into this else and said, yes, thank you. Then it breaks out of the loop. That's why we indicated break here. So basically, that's what we are doing here. So when I tell it, because we are doing it together, you can see, say, oops, that's not a number. Sorry. Oh, I'm running something else. Sorry. So I'm asking for integer now. Because we are running it together, you can see, oops, that's not a number. N try except finally. I will always run at the end. Then it's asking you for another number. So if you give it, let's say, you, because you are the one who wants to see this solution, and see it's not still working, then we give it probably 10 and say yes, thank you, and it actually works fine. So here is a problem here for you. So basically we have this function. You can see we have we have string, and we have integer. I want to find the square of this. So basically I want you to write a try except clause for this for loop, such, because if I run this loop now, it will give me an error. So write a try except clause for this loop such that it will catch all the error, because if you notice, it will actually run only the first one. Once it catches any error, it will not go to the next place. So it will just stop there. And I want it to actually check for everything. So that's what the try except helps us to do. It will actually keep on running until it gets to the final place. So write a try except clause here to check for all the, like, it will check, oh, this is a string. It will tell you, oh, sorry, it can't run this because it's a string. Then check B, then check C, then check 2. So until you can see 2 should actually run, but because the first one has an error, the 2 it will not get to the 2. So pause this video now and try this out. So I believe you've tried it out. So here is my own solution. So basically I said for I in this, try this. You can see it give us an error here. So try this. So it will try this. Then I said this is not a number. So you can see I said this. So I said this is not a number. Let's just use this is not a number. Sorry. So we won't be blowing nonsense to grammar. So this is not a number. Then the next thing to do is just do what again? The for loop does not break, because it's not Python that is catching the error, it is our Excel that is catching the error. So it will keep on running. That's one of the benefits of using the try except clause. Unlike when we actually have error in our code, the Python code actually stops working. But the try except clause helps us to continue running in spite of the bad error we've gotten on the way. So having said that, so if I run this now, you can see this is not a number, this is not a number, this is not a number, and it got to the 4 and actually printed out the correct answer. So that's that about that. Here's another one. So here the error you get here is actually a 0 division error. So you can try this too out. So pause the video now and try it out. So I believe you've tried it out, and actually this is my own solution. So if I run this now, you can see 0 division error. So basically I just indicated the 0 division error here. So when you divide by 0, you get a not a number. That's NaN. If you've done NumPy, if you are interested in learning data science or machine learning or the mathematics behind all those things, you can join my other series on this channel. And please don't forget to subscribe at this point. So having said that, let's move on. So that's not a number. Then unit testing. Basically, we will do unit testing in this tutorial. And what I mean by unit testing is basically you actually checking your code for every condition. Your code doesn't just need to run, because we've tried it here, it's running. The code doesn't need to run. It has to be able to run in all circumstances to be used. So that's what we use unit testing for. And for us to do all those things, to check our code, we actually use a library, we call it Pylint. If I run this now, it will actually tell me requirement already satisfied. But in case you don't have it on your system, please do try and install it. So let's move on to our Spider to actually check our Pylint. I know this tutorial is getting long, but I'll try and rush things so we don't spend too much time here. So let's end this tutorial here, and I'll be seeing you in the next tutorial. Thank you.